Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to explore how we can implement Retrieval Augmented Generation or RAG pipeline in Snowflake Cloud Data Warehouse platform with its Cortex LLM functionality. Okay, so already we have discussed in detail how we can implement RAG using AWS Bedrock, Kendra, Pinecone and several other vector database. So that same base concept we are going to implement in Snowflake, that first we need to read some PDF file or the data can be in some other format. In your case, we have to first read that, split into small chunks. For each chunks we need to get its vector representation using embedding, and then we need to store that in some sort of vector database. Here in this case we'll be storing in Snowflake itself. Okay, and then whenever user want to query something, what we'll do, first we'll convert that query to a vector representation format, and we will try to find out similar chunks which are already stored in our vector database, and then we will create a prompt where we will pass those similar context or similar chunks along with that user question, and we'll ask our advanced large language models to answer the user question based on those context whatever we have provided in the prompt as a chunk, right? That same concept we are going to implement here. So if you have already implemented RAG following my previous video, this will be pretty much straightforward. So I will request you, if you have not watched that particular video, you please go through that first, because that same fundamental concept, same coding we are going to use here. Just the difference will be, instead of only using Python, here we will be taking help of some Snowflake specific feature that can be SQL, that can be directory tables, external stage, etc. etc. Okay. So without any further delay, let us directly jump into the implementation section. So here let's consider I am having a PDF file or document, we can say, which basically explains the UP government's various steps what the government has taken in its second term in last 6 months. Okay, so air connectivity, health infrastructure, and then if you consider film city development, etc., various topics are covered in this PDF file. What we will do, we will create our RAG pipeline and we will ask certain questions from this PDF, and we will see whether our model is able to reply that or not properly, right? So here what I will do, first I will drop a database and create a fresh database for this demo, which is having the name Snowflake LLM POC. So I'll execute that, and here it is executing. Now as part of the first step, we'll have a quick recall how we can work with unstructured data. Okay, for this already I have created a dedicated video. That same concept I'll just reiterate. So for this case, the scoped URL help us while working with unstructured data in Snowflake, right? So what is scoped URL? Just a quick recall. It permits access to a specific file which can be in external stage or internal stage somewhere for a limited period of time in our Snowflake. Okay, it cannot be accessible outside, so that way it will be secured as well. So just a quick recap on our previous demo, what we discussed, that is how we can read a PDF file and get number of pages in it. So that we'll explore or recall once. So here what we are doing, we are creating a function which is having the name count number of pages UDF. This is basically user defined function. It will be taking the file name. This is obviously a scoped URL, and it will return integer. Why it is returning integer? Because in this function we are basically counting number of pages available in a PDF file, which is obvious, nothing but an integer value, right? Language Python, because this PDF page counter we are writing in Python language, and runtime version is 3.8. The external packages whatever will be needed, obviously Snowpark Python we need, and PyPDF2 to interact or read the PDF file and do various operations on it. For that PyPDF2 will be needed. Okay, handler is main function. So main function is the function which will do that actual computation. It will read the PDF file and return the number of pages. Okay. So here as a first step what we are doing, we are importing our necessary modules. Okay, Snowpark files, we are importing Snowflake file. So Snowflake file will basically help us in reading the PDF file. All we need to do is provide the scoped URL via it, and scoped URL already we are passing as function argument, so that one we are passing here. Snowflake file dot open file name, which is basically a scoped URL, and we are opening in read binary mode. Okay, right? And then here we are creating the PDF reader object, and we are returning length of PDF object dot pages, which will return me number of pages available in our PDF file, right? A pretty straightforward code what we discussed in our earlier video also. So here it is executing. Let it get executed. Now Here what I am doing, I am creating an external stage. Okay, so here if you see, we are using S3, this particular bucket. Within that we are having PDF knowledge base, and here suppose our PDF files are available which can act as a knowledge base for our this RAG application. Okay, so pointing to this particular location, we need to create a directory table. Directory table has its own advantage. It is nothing but when we execute list external stage command, that time we get list of files available in our external stage, what is the size, what is the MD5 hash value, when it was last modified, all those information. But if you want to query, then directory table can help us. So that's why I am creating this external stage as directory table. Okay, this also I have explained in detail in my previous video. You can check that particular video for the detailed explanation. I will be providing the link in the description box. Okay, so here what we are doing, I am providing my S3 path and access key secret key based authentication I am using here. For our production system, we can opt for IAM role based authentication and enable true. So this will make sure directory concept is enabled in this external stage, and the stage name we are giving Snowflake stage directory table YT. Okay, so here I will be executing that, and because this directory table is not enabled for auto refresh, I'll manually refresh once. And here it is done. Now if I do select start from directory, and then here we can pass our external stage name. Here you will see it will return a table kind of structure where relative path yogi -2-0_2110022. This is basically nothing but this particular PDF file name we are getting, and size, this is 43,704 bytes file. When it was last modified, it was last modified on 14th September, and then MD5 hash value, E tag, all this information along with file URL we are getting, right? So here I will basically scroll below, and in this query what we are basically doing, we are calling our UDF, which is helping us in getting number of pages available in this PDF file. Okay, so select relative path. Relative path from where I am taking from this directory table. Okay, then count number of pages UDF. Here I am calling my UDF just now what we have created. Okay, now as I told you, this UDF takes scoped URL for a file which is available in our external stage or internal stage. So we are having a function build scoped file URL, where it basically takes two arguments. One is our external stage name and the relative path, and it by default generates the scoped URL which Snowflake can use to read it directly from the Snowflake itself, right? So that we are doing build scoped URL, and this particular thing will generate the scoped URL for our files whatever available in external stage, and that file URL we are passing via this particular function which will help us in getting count of pages available in a PDF file. Okay, so this count of pages we are aliasing as PDF page count from the directory table. Okay, so what this query will do, it will take the relative path, it will generate the scoped URL, it will call the UDF and get the number of pages, right? As simple as that. So let us run it. So here you will see that in this file we are having 3 pages, and if you see here, actually in this particular PDF we are having 3 pages only, first page, second page and third page. That's it. Okay, right? So up to this we have already discussed in our previous video. Now while working with RAG application, the number of pages available in a PDF file will not be helping us much, but rather we need to read the content whatever is available in the PDF file. Okay, right? So I have twisted the function little bit here. So what we are doing, the first part is as it is, just the difference is now this time we need to read the PDF content. Earlier we were just getting number of pages available in it, so return type was integer in earlier function, but this time we need to read the text content within our PDF file, so return type will be string, right? That is a major change. Apart from that, here we are importing our required modules, we are opening it, and then we are creating the PDF object reader, and then here all we are doing, earlier if you see here in this particular function we were just returning PDF object dot pages. For that whatever length we are getting, that we are returning to indicate number of pages in it, but this time we need to read the content, so that's why we are reading the content for each page, and we are appending in all text what we have declared here as empty variable. In that particular variable we are keep on appending each page content, and wherever new line characters are there, that one we are replacing with a space. Okay, this one you can do based on your business context. Here in this case this operation might be more suitable and give better result, so that's why I have used here. Okay, and we are returning all text, right? So I will run this one quickly. And here if I scroll below, now this is the same SQL query how we used earlier for PDF page count, just the difference is this time it will read the PDF content and it will return us. Okay, so the alias name here we can give PDF text. Okay, and we are selecting again from our directory table, so I will run it. And here we will see this is the relative path, this is the PDF text. So let's see whether text is extracted properly or not. So maybe here I will open in a new window and I'll paste the content whatever PyPDF2 has extracted. And if I go completely top to my PDF file, and here if you see the text, UP from connectivity to development, a look at 6 months of Yogi government 2.2. Here also same, UP from connectivity to development, a look at 6 months of Yogi government 2.2. The Yogi Adityanath led Uttar Pradesh government completed 6 months of its second term on Sunday, September 25. If you see here, this text is there. The Yogi Adityanath led Uttar Pradesh government completed 6 months of its second term on Sunday, September 25. So that way, here we are getting it that our PyPDF2 successfully able to read the text content from our PDF file, whatever is available in Snowflake external stage. Right? Now the next step will be pretty much simple. All we need to do, we can use LangChain character text splitter or recursive character text splitter to split this particular whole text into small chunks, perform embedding, store in vector database, and then perform similarity search, get the similar chunks, and then pass via prompt to get any answer related to this particular PDF file. Right? So that one we are going to do next. So here if you see the next layer, what we are doing here, we are going to read the PDF content, get the text data, and we'll split it also. Okay, split into small chunks. Split into chunks, we can write like this. So this particular function is kind of similar like our earlier function, only difference is this time we need to use LangChain module. So that's why we are keeping that one. And apart from that, in our earlier function, we were returning the complete PDF text, right? So that's why return type was string. But this time it will be performing chunking, right? So chunks will be getting as array elements, right? An array it will be returning. That's why return type here we are defining as array. Right? Handler is same. These particular things are pretty much same like earlier. Just the difference is now from LangChain we are importing character text splitter because we need to split this complete big PDF file text data to small chunks and then feed into our LLM. Otherwise, if you pass this very big text, it might exceed the context window and it might forget some informations from the top, right? That context window issue might appear. That's why we basically do chunking. Just a quick recall on theory section as well. So now here if you see the code up to this particular layer, it is pretty much same like what we have implemented just now. That first we are reading the PDF file and then we are iterating in pages, we are extracting the text out of it. Now here is the new addition. We are defining our character text splitter. Separator is full stop. So whenever a sentence ends, that we can consider as a separator. Okay. Chunk size is 200, so at least 200 length chunk we want to keep, and overlap is 25, so that two different chunks will not be completely out of context. They will be sharing certain amount of context, right? And then we are basically using dot split text method and we are passing our text data whatever we have extracted from the PDF file to get the chunks. So split docs will be basically an array where small chunks of our whole PDF text data will be stored, right? That one we are returning. So this particular part is same like how we built RAG application using AWS Bedrock, LangChain and Pinecone. So same concept I have used here. Okay, so I'll be creating this function quickly, and once the function is created we can call it following that same manner how we did earlier. Okay, read PDF and split. We need to pass the scoped URL. Scoped URL we are creating using build scoped file URL by passing the stage name and the relative path from our directory table. Okay, right? So I will run this one. Now this time we should be getting chunked data as an array elements, right? So here if you see relative path is same, but here PDF text if you check this time, here if I hit some enter and put it, here if you see now this time we are getting an array, right? So here array starts and here array ends. Okay, and here in the middle if you see, here this is one sentence and then here this is another one, and then here this is another chunk. Like that way multiple chunks we have got from a single document. Okay, right? Now as a next step, what we need to do, we need to perform embedding. But before doing embedding, what we have to do, we should be making these chunks as a different rows. Currently all the chunks are available within same array in a single row. This way embedding will be difficult, because when passing via embedding model, we need to pass a particular array element at a time, right? Like this first array element we will be passing first, then second array element, then third array element, and so on, right? So what we need to do, we need to flatten this particular cell element into multiple rows, so that each row will contain a particular chunk, and relative path will be taking same value for all those rows, right? So I hope you can easily recall what we are going to use. We are going to use lateral flatten. If you see this code, I hope you can recall. If you want to know more about lateral flatten, you can check the description link. I'll be providing that detailed explanation there. Okay, so here what we are doing, the whole thing, whatever we have executed till now, we are basically giving that particular query the name splitted data. Okay, so it is kind of CTE, we are using common table expression kind of thing, right? Instead of using subquery. And splitted data here we have defined, and then here we are referring that select star from splitted data, and we are flattening the PDF text split, that is basically this particular one. If you see, PDF text split is the column which we want to split into multiple rows, so that one only we are doing here. So just minimize that, and here this is how we are writing the code, lateral flatten PDF text split if. Okay, and we are currently selecting everything. Let's see how the result we will be getting, and then we can select specific columns out of it. So we'll flatten the data. So here we have got the data. I'll just zoom out little bit to show you the data how it looks. Relative path is same, the file name what it is taking, then the PDF text split, it basically contain the original array. Okay, if you select any one element here, it will basically contain that actual array which is having multiple chunks, right? Now here if you see sequence, this particular column might not be that much important, key is not that much important, path also you can ignore. So index is very important, I will come to that, but before that most important column is value column. So what it is doing, the value column basically contains the array element, okay, one array element in one row or one cell we can say. So if you see here, in our case, the first array element is this one, UP, from connectivity to development, a look at 6 months OGI government 2.2. And if you check the first element here, the same thing basically it contains here, right? So basically this particular array where all the chunks were there in a single location, single cell, that one is splitted now into multiple cells, okay? And this index is basically indicating what is the index position for that array element what is sitting here. Like this is the first array element, that's why index is 0. This is the second array element, that's why index is 1, and so on. So maybe relative path, index, and then value, these three we can extract for our required information. Rest are redundant columns, we can ignore that. So that's why here I have done that, take specific columns from the flattened data. The flattened part we have given the name F. So now this time what we are doing, we are taking relative path, index position, that this chunk is available in this index in our PDF file, and then the value part. Okay, so that one we are extracting. So if I run it, so here you will see that beautifully we are getting the clean data now, and we are moving towards the RAG application. So now what we have done, we have read our PDF file, we received the chunks out of it only using SQL and UTF. Okay, but if you see each chunk, it is starting with double quotation and ending with double quotation also, right? If I just make this bigger, here you will see ending double quotation is also there. That might not be needed, so all I am doing, I am using trim function to trim the double quotation, as simple as that. So I'll execute this one as well. So it is done. Now the data looks much cleaner. So here if you see, the double quotations are removed. Perfect. Now what we'll do, will perform vector embedding. Okay, and what is the code? Already I have discussed in my previous video that embed takes 768, or if needed you can take some other embedding model for vectorization. Okay, so here this particular LLM model I am choosing, and the value part, that is basically these are the chunk elements, right? These are basically f.value, what we used earlier. That one we are passing to get the embedding representation or vector representation. Okay, so as embedding vector, this alias name we are giving, that's it, no other change. So here we can perform vector embedding. I can run the code, and here you will see that along with relative path and then index position and the actual text, you will be getting the embedding vector representation as well. So here if you see, this is the data and embedding vector we are getting. So this embed text 768 convert any input text to 768 dimensional data. That 768 dimensional vector we are getting here. Okay, not only that, I have taken one more important column, that is size. Size one anyway we are getting from the directory table itself, right? In the beginning itself this particular content was there. If I just execute select start from directory table pointing to our external stage, we were getting the size also. Maybe for our future reference we want to store the size of our PDF files from the external stage as well. So that's why I have taken the size column also in our processing. So here we are doing vector embedding, right? So if you observe this size column also I have added. This may be helpful in future to understand PDF file size. If that is available in Snowflake, from there only directly we can query. We no need to go to S3 again and again, right? That's why we have taken the size column. I hope you are getting it. Now the next step is pretty much simple. We need to store that in Snowflake table. That will be acting as a vector storage or vector database in our case. So here we have given the DDL command for our table, docs chunk table. So relative path, basically the file name, then size, then index, chunk, and embedding vector. Whatever is available in this query, that we want to store. So that's why based on that I have created the schema for our table. Okay, so here I will execute this query, and then a simple insert command I am executing to store the data whatever we have created earlier in this table. Okay, once that is done, here I can execute select start to show you the data. So 25 rows inserted because the LangChain has chunked our original PDF file into 25 small chunks. And if I do select start from table, here you will see this is our table. So currently this is our vector storage. Okay, we can perform semantic search on it. So let's see, suppose user is asking a question, how many people received Ayushman card in UP? So if you check our PDF file, obviously it will be available somewhere in healthcare section, this section. If I just go to the next page, here if you see, apart from this 6.51 crore people of the state have received Ayushman card to avail health insurance cover up to 5 lakh, right? So this particular part is important. So when we will ask this particular question, what we need to do? First we need to get its vector representation. Okay, now once the vector representation we get, what the Snowflake should do? Snowflake should try to find out most similar chunk in this storage data. So for that we are basically executing vector L2 distance. Okay, either L2 distance you can use, or cosine similarity or cosine distance you can use. There are different distance calculation mechanism are available, and we need to get those chunks for which the distance is minimum with respect to the embedding vector for this text, right? So that's why I am doing order by. It will be sorting the data in ascending manner of distance, and the minimum distance element will be available in the top. That's why I am executing limit 1 to get the most similar chunk for this user question. Okay, right? So I can execute that to get the most similar chunk, and here if you see, this is the most similar chunk it is getting. Apart from this, 6.51 crore people of the state have received Ayushman card, right? And now I hope you are getting it, how we can complete our RAG build. That is, this is the context. Now if the user asks this particular question, all we have to do, we have to pass this thing as a context in our LLM prompt and then ask this question, right? That way our LLM model will be able to reply. Okay, so now let's see that part. It is very simple. what I am doing here, this particular chunk is basically the information what our LLM model will be using. Okay, before that we need to add some string that answer the question based on the context, and here we are passing the context. Okay, this one will be passing, and then here we are appending the question, and the question is how many people received Ayushman card in UP. Same question we are asking, and then we are expecting the answer. So let's see how the concat function is creating the prompt. So here this is the prompt. I'll copy that and show you once. So this is the prompt we are getting. Answer the question based on context, be concise. And the context is here the most similar chunk we are passing, and then we are asking the question how many people received Ayushman card in UP. So obviously any modern state of the art LLM model will able to reply based on this context or based on this prompt, right? So that we will test now. So this whole query we will pass via LLM model now using Snowflake Cortex complete function. This one also I have discussed in my previous video. The complete function basically expect two arguments. One is the LLM model name and another one is the prompt. Based on prompt it try to reply. As simple as that, just like how you ask question in chatgpt. Okay, so here what we are doing, we are taking Mistral large and we are passing this particular prompt whatever our concat function is generating. Okay, and we are getting the response out of it. So I will run it. And here you can see beautiful response we are getting. 6.51 crore people or 65.1 million people have received Ayushman card in UP. Okay, how it is telling? It is telling based on this particular context. Here we have only given 6.51 crore, but LLM using intelligent manner it is deriving this extra information also, or 61.5 million people. This kind of thing it is appending and it is returning the concise answer. Okay, right? I hope you are getting it. This way we can easily build the RAG application, right? Now another point is important, that it is not necessary that we need to always take the most similar chunk. Sometimes we might need to take more than one chunk, maybe 2-3 chunks to provide the answer in an accurate way. So that also will be observing. It is very simple. All we can do here, we are passing limit 2. Instead of taking top most similar item, we are taking top 2 similar item. Okay, so that way it will be returning top 2 most similar chunks. That also I can show you separately. So this query if I pass, here it will be giving me 2 similar rows. Okay, so one is the Ayushman card, another one if you see, the government recently inaugurated a health ATM at Gorakhpur and is installing health ATM at 4,600 primary health center of the state. Okay, so the second most similar chunk is also healthcare related only. Sometimes this might also help us in answering, right? Now what we need to do, we need to pass both of these statements via our prompt. So these are 2 different rows. So all we can do, we can take help of list aggregate to combine into one single string, and here we are putting comma separated one. So that way it will be appending 2 or n number of similar chunks into one single string and create a single prompt, right? So here if you see this time, if I just copy my prompt, here this is the prompt we are getting. Okay, answer the question based on below context, be concise. Earlier context whatever we have given, that also available, and apart from that the second most similar chunk, that the government is recently inaugurating a health ATM at Gorakhpur and blah blah, that also here it is providing. Okay, and then it is asking the question how many people have received Ayushman card in UP. Okay, right? So this way we can pass the multiple chunks via our prompt. That also I hope you are getting it. Now let's see that if we ask some question based on these multiple chunks, how it will answer. So this is one example. If you observe our document, here some important points around film city is written. Okay, so that one let's experiment. That tell about film city project in UP point wise. Okay, here also in the question we are putting that same. So whatever question user will be asking, that same thing we need to use for similarity search in the above part as well. Okay, so on this be careful, don't put different text while similarity search and while asking question. That time it will not able to reply properly. Okay, and here we are taking top most 3 similar chunks, and here we are asking the response. So this time I can run it. So here if you see, it has returned point-wise response. See, 6 point it has returned. The Film City project is proposed to be set up in Noida, Uttar Pradesh. It is dubbed to be country's biggest and most beautiful film city. The project aims to connect youth of UP with world-class job opportunities, right? Like that way around film city, whatever points are there, it has given point-wise. You can ask maybe another question that give 5 points how UP government is planning for new job opportunities, and that same question we are asking here, right? So I will run it. And here we are getting the response. So I can copy that one and paste that here. So if you see the 5 points from the document, it has tried to extract. Construction of a new project worth rupees 10,000 crore in 1,000 acres. So from where it has taken? It has basically taken from here. So 10,000 crores, about 1,000 acres. It is basically construction going on and it will give employment opportunities, right? So it has found out this as a point with respect to user question. Boosting tourism in UP, which will create new jobs opportunity in this sector, right? From where it has got somewhere, let's see. So basically it is taking from here. It will also give new energy to tourism of UP. So via tourism, obviously earning will happen, right? The third point, if you see, enhancing air connectivity by building new domestic and international airports, leading to job creation in the aviation sector. Okay. So it is basically taking from this particular section, increasing air connectivity. So like that way, from different place of our PDF file, it is trying to find out similar items and it has tried to reply. Okay, right? So this is how, using simple directory table, Snowflake Cortex, complete function and embed function, you can create RAG application in Snowflake, and from there you can utilize that in chatbot, maybe FAQs. All these different possibilities will be opened only using Snowflake Cloud Data Warehouse platform. You no need to go somewhere else, right? This is all for this video. The complete code I'll be providing in the description box. Try to play with it, try to explore the reference links, whatever I'll be providing. That way you'll be understanding more out of it. So if you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.